Hello and welcome back to Mrs. Riley's Maths videos. Today I'm working through further coordinate geometry of the circle. This is a Leaving Cert Ordinary Level topic, and what we're doing is we're really just at the start of it. I recorded a video previously introducing us to the idea of the equation of a circle, and what I'm going to do in this class, this video, is to work through a couple of the slightly more extended questions around a circle with centre 0, 0 and radius r. So remember, the key defining feature of a circle is its radius length. That makes us know how big it is, and its center. That tells us where it's located on the diagram, or where it's located on the coordinate plane. So an equation with a circle has an equation, and a circle with center 0, 0 and radius r has the equation x squared plus y squared equals r squared. Now we know that because the exercise that we've been working on has been dealing with all those circles, but we're going to assume that we don't know that, and we have to just say that each time to remind us about it. I'm working from the textbook Active Maths 3, exercise 19.1, page 574, but I've written out the questions here so that even if you don't have that textbook, you can follow what we're doing. So in this question, a circle has equation x squared plus y squared equals 4. We're being asked for the coordinates of the center, the radius of the circle. We're asked to construct the circle, and then using the formula c is equal to 2 pi r, find the length of the circle. So this is actually the formula for the circumference of a circle, which is another word for the perimeter or the length of a circle. Okay, so that's what c is. So let's start off. We've got x squared plus y squared is equal to 4. We're going to compare that to x squared plus y squared, which equals r squared, which is the equation of a circle with center 0, 0 and radius r. Looking at this, we can see it's x squared plus y squared, x squared plus y squared. So the first thing is the coordinates of the center are 0, 0. This circle has a center 0, 0. Secondly, the radius of the circle, well, r squared and 4 are in the same position. So r squared must equal 4, so r must equal the square root of 4, so r is equal to 2. So our radius length, that's what r is 2. The next thing we're asked to do is construct the circle. So I'm just going to, if I can find a ruler here, if it hasn't vanished. Oh, thank you very much. So here is my circle. Now I should be using pencil for this, but it's all right. I'll use a pen for now. And I should be using a compass, which I'm not using. Maybe I have a compass in my pencil case. Oh, I have a compass. I'll just have to, oh, that's a divider. Do I have a compass here? Bad preparation. So maybe I'll get into the hat. Oh, here I've got a compass here. I just have to put a pencil in it. So, thank you. I've got somebody here to help me with these things. So here we've got a pencil and a compass. Okay, to make sure my circle's accurate. I've drawn my x-axis and my y-axis. I'm going to put in my numbers. 1, 2, 3, 4. 1, 2, 3, 4, 5. -1, -2, -3, -4. And -1, -2, -3, -4, -5. It doesn't really matter what numbers I go up to on my axes, as long as I'll be able to include a radius of 2. So if this is the center of the circle and it has a radius of 2, there's a radius there. That's going to go as far as there, it's going to go as far as there, it's going to go as far as there, and it's going to go as far as there. So remember, the radius of a circle is the distance from the center to the edge of the circle. Now, let's see, this is actually quite a small circle to draw. Let's see how I get on. So I'm plonking the compass at the center, and now I'm drawing a circle. Okay, so this now, because I'm using a compass and I used a ruler and whatever, this is now a construction. Previously when I've done these, I've just done a sketch. But as you can see there, not very well, but you can see well enough, I've now drawn a construction. I've used a proper compass. I know that everything on the edge of this circle, on the outline of the circle, everything is 2 units away from the center. So this is my circle construction. And then finally it says, using the formula C is equal to 2 pi r. So this is the circumference we've just said, which is the same as the length of the circle. Pi, as you know, is a constant, 3.14 or 22/7, or just pi on your calculator. And r is the radius length. So they're saying, using that formula, find the length of the circle to 2 decimal places. So I'm just going to do that on my calculator. So here I have 2c is equal to 2 by pi by my radius, which is 2. So 2, can you see that? I put in 3 there by accident. 2 by pi, which is shift, and then this button down here, shift by 2 by pi by 2 equals, now it tells me 4 pi, but I was asked to give my answer to 2 decimal places, so I'm going to have to press the SD button, and it tells me it's 12.5663. 12.5663 to 2 decimal places. That's the 2 I'm keeping. 12.5. Remember, if this number that I'm losing is bigger than 5, then I round up by 1. So 12.57 to 2 decimal places. Okay, hopefully that makes sense. Now here's the next question. A line segment joins A minus 5, 1 and B 5 minus 1, and it's the diameter of a circle. Find the center of the circle. So the first thing I'm going to do, actually, I'm not asked to construct this one, I think. What I'm going to do is just to draw a sketch so that we can visualize what's happening. So here's my set of axes again. Here's X and this is Y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, -1, and so on. Okay, so what I'm going to do here, once I've plotted my axes, or I've drawn out my axes and put on my scale, which if you notice I'm using the little squares as my guidelines for where to put my numbers, I'm going to draw my 2 points, minus 5, 1, which will be here, and 5 minus 1, which will be here. And what we're told is this is a line segment, which means a bit of a line that joins 2 points. Okay, so there's my line segment, and it's the diameter of a circle. In other words, that my circle has those 2 points as the end of it. Okay, now looking at that, it seems fairly clear to me that the center of that circle is going to be at here, 0, 0. So let's see. So the first thing is find the center of the circle. It looks to me that it's halfway between minus 5, 1 and 5 minus 1, which would make sense, because if this is a diameter, the center is going to be halfway along the diameter. Okay, so this is a diameter, which means a line that joins one side of a circle to the other side through the center. Okay, there's a diameter. It goes from one end to the other end, but goes through the center. So the point that's halfway between these, well, if you notice, to get from minus 5 to plus 5, I go all the way along here. Halfway along is going to be 0. Now I could use my midpoint, which we might have to use later on for the other questions. Midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. So I could use that. I probably don't need to, but I'll use it anyway. That was x1, y1, x2, y2. I can see that actually it's fairly obvious that the center is 0, 0. Okay, so let's just draw it anyway, now that I have my compass to hand. So if I put the center at 0, 0 and I draw my line, sorry, my circle using my compass. Oh, this is very nice. Okay, there's my circle. As you can see, it's got a diameter joining minus 5, 1 and 5 minus 1. Center is 0, 0. The radius of the circle, which is part 2, well, let's look and see. Can we tell what the radius is? Let's take a center point and a point somewhere on the circle. Well, there's a center point and there's a point somewhere on the circle, is it? Is that exactly at minus 5? Looks to me like it's at minus 5. Looks like it's actually just slightly above minus 5. So how am I going to work this out? Now, what we do know is that the equation of the circle is x squared plus y squared is equal to r squared. Now, if I know that one of my points minus 5, 1 is on that circle, well, then if I was to sub it in to my equation, then I should get r squared, shouldn't I? If that point is on the circle and we know that it is. So I've done that. 25 plus 1 is equal to 26, and that equals r squared. So r squared is equal to 26. R is equal to the square root of 26. I'm not actually going to find out what that is. It's about 5 point something, because I know that r squared is 26. So r is the square root of 26, and the next bit tells me to write down the equation. And I know that my equation is x squared plus y squared equals r squared. So my equation is x squared plus y squared is equal to 26. Okay, I hope that makes sense. So we knew the center, we didn't know the radius. We could have used the distance formula to find the distance from here to here, but actually it's as handy to just sub in the point that should be on the circle, and that gives us r squared, and then we can find out the radius. Part 4. Using the formula A is equal to pi r squared. So this is area. This is from your area and volume tables and formula book. Okay, our formula page. A is equal to pi r squared. So we've got to work out what's the area of this circle. So it's equal to pi by the radius squared. So the radius is root 26. Radius squared we've seen is 26. So it's pi by 26. So pi by 26 is going to be shift pi times 26 equals 26 pi. And it tells me to give it 2 decimal places. So get my SD button, 81.6814. 81.6814. If that's going to be to 2 decimal places, it's only those 2 numbers I want. So 81.6, that's less than 5, so it doesn't round up. So 81.68. Okay, then part 5. If the area of the square is the area of the square with vertices, so it's this bit here, is the area of the square with vertices 0, 0, 9, 0, 9, 9, and 0, 9, is it greater than the area of the circle? Explain your answer. So now I wonder, sorry, you can see I'm doing this in the evening and it's a bit darker, that's why there's shadows. I wonder if I could even plot these points, because if I could, it might make it easier to see what's happening. So 0, 0, 9, 0, 6, 7, 8, 9, 9, 0, 9, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's up here, that's all right. So that's 0, 9, and 9, 9 then will be up here. So here's my square. Now, what is the area of that? The area of that square is the length by the length. And the length of that side, L, is equal to 9. So actually it's 9 times 9, which is 81. So we have that the area of the square is 9 by 9, which is 81. We have the area of the circle is 81.68. Area of the circle, so the area of the square. So the area of the circle is 81.68, which is bigger than the area of the square. Area of the square, which I guess is because it kind of overlaps, doesn't it? Okay, I've got to go. So I hope that's helpful, and I'll talk to you soon. So the main thing to take away from this is a circle with center 0, 0 and radius r is x squared plus y squared equals r squared. If you have a diameter, it has 2 endpoints, and the halfway point between those 2 endpoints is going to be the center of your circle. That'll be important later on with the other type of circles we're going to look at. Take care. Bye-bye.